Hi everyone, welcome to today's video. In this video, we are going to discuss the first paper of JEE Mains 2024. That is 27th January Shift 1 paper. If we talk about the chemistry paper, we are going to deal with all the three streams of chemistry. First, we'll talk about inorganic chemistry, then physical, and then we'll move to organic chemistry. If we talk about the level of the paper, it was very simple. It was similar to the level of JEE Mains 2023 paper. And the number of questions, if we talk about inorganic and organic section, had relatively more number of questions. Physical had relatively less number of questions. Since this paper is memory based, since all these questions are memory based, there may be one or two mistakes or one or two data insufficient questions. Okay, so bear with us and let's start. So the first question says, which of the following has maximum magnetic moment? If we talk about magnetic moment, that is basically root of n into n plus 2. And n is the number of unpaired electron. If we see the number of unpaired electron in 3d3, it is basically 3. If we talk about the number of unpaired electron in 3d6, it would be 4. And if we talk about the number of unpaired electron in 3d7, it is going to be 3. So the maximum number of unpaired electrons are present in d6, and hence the magnetic moment would be maximum in 3d6. Moving on to the next question. So the assertion is, the boron has very high melting point, that is correct. Boron has strong crystalline lattice, that is also correct. Boron is a crystalline substance, it is a crystalline element, and it also has very high melting and boiling point. Both of these statements are correct. And I can also say the reason is the correct explanation of the assertion. Next question is directly from molecular orbital theory. If we talk about CO basically has 14 electrons, and 14 electron means it is isoelectronic to N2. Let us see NO plus. Again, NO plus is also having 14 electrons. So both of these are isoelectronic to N2. And if we talk about N2, the bond order is 3. So these two will also have a bond order of 3 each. So the correct answer would be 3 plus 3, which is 6. Quite an easy question from molecular orbital theory. Next, how many of the following have +4 oxidation of central atom? See the level of the JEE Mains questions this year. It's quite simple, no? If we talk about BaSO4, it is Ba plus 2 and SO4 2 minus. And in sulfate, we know sulfur is in +6 oxidation state. So that is not our answer. SOCl2 is basically having an oxidation state of +4. 4 bonds connected to electronegative elements. Similarly, SF4, it is also having an oxidation state of +4. You can calculate through the structure, or you can calculate using the formula that sulfur has an oxidation state of X, then X plus 4 into -1, overall charge is 0. Through both ways, you will get the answer as +4 only. So these two are correct. H2SO3 is also correct. Sulfurous acid has an oxidation state of +4. Sulfuric acid has +6. So if we see this is a derivative of sulfuric acid. This is pyrosulfuric acid. Structure is like this. And the oxidation state, as we can see through the structure, is +6. The structure always tells us the correct oxidation state. Okay. So this is not correct. SO3 is having an oxidation state of +6 again. So that is not correct. Our answer is 3. Moving on to the next question. PbCrO4 plus NaOH hot excess. So if we talk about PbCrO4, the oxidation state of Pb is +2. And Pb is reacting with NaOH. If the moles were limited, we would have gotten PbOH whole twice. But if we have excess of NaOH, what happens? It will form a complex PbOH whole 4 2 minus, a soluble complex. If we talk about this, we can see the coordination number is 4 and overall charge is -2. That means it is dianionic. Whenever the net charge is -2, it will be called as a diionic compound. So next question. The reaction of NaCl with H2SO4 and K2Cr2O7. This is an excellent reaction. This is directly from qualitative analysis. This is a characteristic test of chloride ion. That is how we determine that we have chloride ion in our solution. We react it with potassium dichromate and we have H2SO4. It just provides acidic medium. So chloride ion basically gets converted to CrO2Cl2 on reaction with K2Cr2O7. This is called as chromyl chloride. Chromyl chloride is red in color. We have red fumes, and apart from this, the other products would be just sulfates of the respective metal ions and water as well. Now this is our A, and this A will react with aqueous NaOH. So CrO2Cl2, it reacts with NaOH and we will get Na2CrO4. This is called sodium chromate. Sodium chromate is yellow in color. We are going to get a yellow solution. All these reactions are characteristic reactions which we have discussed in qualitative analysis. Right, moving to the next question. Spin magnetic moment. Again they have asked a question on spin magnetic moment. We know mu is n into n plus 2, where n is the number of unpaired electron. So here we have d block elements. If we talk about iron, iron is 26, which is 3d6 4s2, and we have vanadium. So if we talk about vanadium, that is 23, so we are going to have 3d3 and 4s2. Let us see the oxidation state. Here we have iron in +3, here vanadium in +2 and iron in +2. Also we have all the ligands as weak field ligands, so we wouldn't do pairing until necessary. So if we talk about Fe+3 in the first case, it is 3d5. As we know, the electrons are first eliminated from the outermost shell. So 3d5 is basically something like this. T2G has 3 electrons, Eg has 2 electrons. Vanadium is V+2, so we are going to have 3d3, and there is no doubt 3d3 will have 3 unpaired electrons. Next, let us talk about Fe+2. The Fe+2 has 3d6. Now we will have to pair an electron because we do not have a choice. These are 5 electrons, the 6th electron would be paired. So 4 unpaired electrons. The maximum number of unpaired electrons are present in P, so it will have highest magnetic moment, then in R, then in Q. So PRQ would be our answer. Quite an easy problem from coordination compounds. Next. Now, this is a good question. Generally, students do not remember the electronic configuration of lanthanoids. And take a note that we can have another question in which they can ask the electronic configuration of another lanthanoid in one of these attempts. So let us see. If we talk about neodymium, it does not have an electron in 5D. There are only 3 lanthanoids which have electron in 5D. One is cerium, then is gadolinium, and the third one is lutetium. So neodymium wouldn't have electron in 5D, it will have electrons in 4f and 6s. The nearest noble gas is xenon, which is 54. So we will write xenon and then we will put electrons in 4f and 6s. So it would be 6s would be having 2 electrons and 4f would be having 4 electrons. This would complete the total count of 60 electrons. Right? Good question. Next, So again, this question is incomplete. There would have been other options, but since this is memory based, we are unaware of that. H2H2O7. So this is similar question we just did. H2H2O7 has an oxidation state of +6. And it is pyrosulfuric acid or disulfuric acid, and this is sulfurous acid. So it is having an oxidation state of +4. Quite an easy problem. Next, 4F and 5F series are written separately in periodic table in order to preserve principle of classification. Exactly, because if we talk about S block, then we have D block and P block. We want only 10, I can say, groups here. I do not want 18 groups. So, sorry, 14 groups. So what do? We basically have F period, I can say, at the bottom. So we do not keep the F electrons, that is lanthanoids and actinoids. We do not keep the elements containing F electrons here. So we want to preserve the classification, right? So first statement is correct. If we talk about the second question, S block can be found on Earth in pure form. No. S block elements are very reactive. If they are very reactive, they usually form salts. Okay, so they will not be found directly in their pure form. It will be found in the form of their salts. So this is incorrect, right? Statement 1 is correct. Statement 2 is incorrect. Moving on to the next question. Which halogen does not show variable oxidation state? Fluorine is the most electronegative element. It can only show an oxidation state of -1. If we talk about F2, then it is the oxidation state of 0 as well. But it is limited to 2 oxidation state. On the other hand, if we talk about iodine, chlorine and bromine, its oxidation state can vary from -1 to +7. So the answer is first. Direct question from P block. So that is the end of inorganic chemistry. Let us start with physical chemistry now. So the first question is the mass of methane required to produce 22 grams CO2 upon combustion. So direct question, we have to take methane and we have to react it with oxygen, because that is combustion reaction, and we will be getting CO2 and H2O. If we talk about carbon, it is balanced. Hydrogen is 2. Actually, we do not need to balance the reaction as well, because we know this will be in the ratio of 1:1. So if we are getting 22 grams, that means we are getting half mole of CO2, that means we are getting half mole of CH4, and that means we are getting half into 16 grams, that is 8 grams of methane are required. 8 grams of methane is required to produce 22 grams of CO2 upon combustion. Very easy. Let's go to the next question. For negative deviation from Raoult's law. So basically negative deviation means PT is less than P0A XA plus P0B XB. And now what we mean to say is if we have AA and BB, finally we are getting AB, and the volume is lesser. If the volume is lesser, that means the interactions are getting better interactions in AB. We know delta V is less than 0, delta H is less than 0. So in case of negative deviation, we are getting less vapor pressure. If we are getting less vapor pressure, correspondingly boiling point would be higher. So the boiling point has to increase and the vapor pressure has to decrease. Quite an easy question from Raoult's law. Next question is directly from ionic equilibrium. So if we talk about ammonium carbonate is composed of a weak acid and a weak base. Basically it is a salt of weak acid and weak base. This is formed from ammonia, or I can say ammonia solution, which is NH4OH, and carbonic acid. If we talk about carbonic acid, it is relatively quite weak, and this is weak but not that weak. Okay, ammonia is not that weak, so relatively the ammonia's nature will dominate, and we know ammonium carbonate is basic in nature. If we talk about a salt of weak acid and weak base, I can take another example, CH3CONH4, let us say. So we know that the pH for this salt is determined by 7 plus half pKa minus pKb. Or if we talk about the hydrolysis constant, it is Kw by Kn into Kb. So the pH or the acidic nature or the basic nature of the salt depends upon Ka and Kb both. So this statement is also correct. Right? Next, number of electrons present in all the compounds filled subshell having n equal to 4 and ns as plus half. This English makes no sense, but yeah, if we talk about the number of electrons which are in n equal to 4, if we talk about n equal to 4, corresponding to n equal to 4, we will have 2n square electrons, and 2n square means 2 into 4 square, which means 32 electrons. And obviously, for example, if we just consider an orbital has one electron in positive spin and one electron in negative spin. So out of 32 electrons, 16 are going to be in a clockwise spin or an anti-clockwise spin. Basically, I can say it will be having 16 electrons will be having spin quantum number of plus half, 16 will be having spin quantum number of minus half. So the answer to this question is 16. This question is directly from atomic structure. A student who has just passed class 10th can also answer this question easily. Next question is from chemical kinetics. This type of questions are very common in CBSE exams, state exams, and these questions are oral. And if you see here, if we are changing the concentration, if the concentration of HI is doubled, you can see the rate. And if I divide the rate, 3 into 10 to the power minus 3 divided by 7.5 into 10 to the power minus 4. This is basically 30 by 7.4, which is 4 times. So if I have doubled the concentration, I can see the rate is getting 4 times. If the rate is getting 4 times, I directly know that I will be having the HI, the order of HI is 2, right? Because if it doubles, the rate will get quadrupled, right? Very easy question. Next, the question is from thermodynamics, and if we talk about this question, we have an ideal gas. It is expanding isothermally but against a constant pressure. As soon as you hear this, you should understand that we have an irreversible reaction. Okay, an irreversible process, sorry. This is an irreversible isothermal process. If the process is irreversible, I know the work done can be calculated as minus P external V2 minus V1. And if the process is isothermal, we know temperature is constant, and if temperature is constant, delta U has to be 0. And since we have to calculate the amount of heat transfer, we know delta U is Q plus W. If delta U is 0, Q is minus W, or I can say Q is plus P external V2 minus V1. We'll have to take care of the units. So let us see if we talk about P external. It is 80 kilopascal. So 80 into 10 to the power 3 Pascal. And if we talk about V2 minus V1, that is 15 decimeter cube. Okay, so if we talk about 1 decimeter cube, that is 10 to the power minus 3 meter cube. So if we talk about the units, this is 80 into 10 to the power 3. Pascal is basically Newton per meter square into 15 into 10 to the power minus 3 meter cube. This goes away. This is Newton meter, that means joules. So the answer is 80 into 15 joules. 15 8s are 120. So we have the answer is 1200 joules. right? Moving on to the next question. The mass of silver displaced by a quantity of electricity which displaces 5600 ml of O2 at STP. So basically, if we talk about the number of equivalents, right, in this type of questions, what we can do is to equate the number of equivalents of Ag and O2, right? For a chemical reaction, we have studied it in equivalent concept. We can equate the equivalents of any two species, be it reactants or products. Now if we talk about Ag, what basically must have happened is कि Ag plus is reacting with electron to form Ag. So if we talk about Ag, the N factor would be 1. And if we talk about oxygen, so oxygen would have been formed from water. Now on oxidation of water we can get O2. So if you check the change in oxidation state, this is 0, this is -2, it is 2 per oxygen. And if we talk about O2, the N factor would be 2 into 2. Why 2 into 2? Because there are 2 oxygens here. So if we talk about the number of equivalents of Ag, that would be the moles of Ag into N factor, which is 1. Next we talk about moles of O2 into N factor, which is 4. So the moles of Ag would be the mass divided by the molecular mass or the atomic mass, which is 108 into 1. The mass of O2, or I do not have mass, I have volume, so I can calculate the moles by 5.6 liters divided by 22.4. And this is 5.6 liter divided by 22.4. Taking the old conventions, this value overall is 1. So through this I'll get the value of W as 108. Okay, so that are all the questions of physical chemistry. Next we are moving to organic chemistry. Which compound is most acidic? This type of questions have been asked hundreds of times in your class as well as exams. Which can lose out of these four, which compound can lose H plus easily? It is this active methylene group. And you know, if we have an compound, if it can lose H plus, the species what we get is a conjugate base. And if we talk about this conjugate base, it is stable because it is highly stable due to the delocalization of the negative charge over the two oxygens, which is not possible in the other cases, right? So active methylene group is most acidic. Here if we abstract the hydrogen, basically when the hydrogen is lost, we'll basically get a conjugate base which is stabilized but not as stabilized as this conjugate base, and that is the case in rest 3 cases. So the third one is most acidic. Now they are asking which one is the strongest Bronsted base. So if we talk about a base, the best base is something which can donate its lone pair easily. Anything which can donate its lone pair easily is a very good base. If we talk about the first nitrogen, its lone pair is in conjugation, it cannot donate. Second one, you can see the lone pair is making this compound aromatic, so it will not prefer to donate. If we talk about the third one, the lone pair is free. If we talk about the fourth one, the lone pair is in conjugation for some time. So I would say the third one is most basic, as the lone pair is free all the time, it can easily donate its lone pair. Right? So that is the best Bronsted base. Oh my god. If we talk about this question, they are asking what happens in SN1, what happens in SN2. SN1 reaction, a student who has just studied NCERT of haloalkanes and haloarenes, each student knows that SN1 is going to be racemization. We get a racemic mixture if we have one chiral carbon in the reactant, and in SN2 we know inversion takes place. And the racemization is basically retention as well as inversion, the mixture of both of these. So first one is racemization, then we have inversion. Second option is correct. Next, which of the following has maximum enol content? So we can make the enol forms of all of these. The first one, if we make, I think if I make this, you have your answer, because this enol form is aromatic. I do not want to see the other forms, but let me make them as well. So in the first case, we know the arrow is shifted towards the enol form. Enol form is more stable. Here we have this. In the third case, I can say I have something of this sort. In the fourth case, I can have something like this. But again, there is no other enol compared to this among these three. This is the most stabilized enol form because this is in its aromatic form, right? So it has maximum enol content. So again, a question from GOC. You can see the question is to compare the acidic strength of the following compounds. The compound which can lose its H plus easily, basically I can say which can form its conjugate base easily, or I can say the stability of conjugate base, if it is higher, the acidity of the compound would be higher. We know this. So if I make the conjugate bases, here we have O minus, O minus, O minus. First of all, you should know phenols are more acidic as compared to alcohols, right? So 4 should be the last. Now out of all these options, you can see in the second case we have 2 electron withdrawing groups. So the negative charge would be more stabilized in the second case, right? After that we have NO2, 1 NO2 that is withdrawing. OCH3 is a plus M group, it is electron donating group. So that is not good. So first would be, so the compound which would be most acidic is second, then we'll move to first, right? I hope that is fine. And after that we have phenol and this. In this case we have just a hydrogen which is neither donating nor accepting. So which is good. We do not want any donation. So the better is the third one. Then we will have the fifth one, and at the last we'll have the fourth. So A option is correct. So I think this question can be found in my lecture notes or in the lecture notes of lots of teachers. This is quite an easy problem. In this question we have to use the lowest locant sum rule. The sum should be the lowest. So we should start from here because we will have 2 methyls on 1. So that would be 1, 1 and 3. The silly mistake which students make is they would consider this 1, 2 and 3 because they will say, sir, alphabetically the first should be assigned to ethyl because alphabetically E comes first. Right? That is not the case because this would be 1 plus 3 plus 3, which we do not want. So it would be 1, 1 dimethyl 3 ethyl, the first option. Cyclohexene is classified as, how can a cyclohexene be classified as an aromatic compound or a benzenoid compound? It is not correct, right? This compound is cyclic. Generally cyclic compounds are called as alicyclic compounds. Acyclic, we know that it doesn't have a cycle. Cyclohexene is a alicyclic compound. Which of the following is polar solvent? So as you know, CCl4 is a perfectly tetrahedral structure. So it will have a dipole moment of 0. This does not have a perfect structure, so it would have some dipole moment. It is a polar solvent. CO2, we know it is non-polar and also it is not used as a solvent. Alkene is also non-polar. So the correct option is chloroform. CHCl3 is a polar solvent. It has some dipole moment. When nucleotide forms dimer, the linkage present between is, how can we have a disulfide linkage? How can we have a glycosidic linkage? How can we have a peptide linkage? This is the case for basically amino acids, right? We do not have, nucleotide is not an amino acid. It is not a carbohydrate, right? Disulfide linkage is usually present in some of the amino acids only. If we talk about phosphodiester linkage, yes, we know if we have a sugar like this, base is connected here, and then we connect phosphorus like this, right? So basically 3 and 5 position, we have a phosphodiester linkage in nucleotides. A classical question from biomolecules. How many groups show meta-directing effect on benzene ring? My god, how many questions they have asked from GOC in this paper. Everybody should do GOC in a very structured fashion, because they are asking a lot of questions from GOC. So anything which can donate electron pair, it will be a orthopara director. And basically anything which has plus M is present here, it is orthopara. If we talk about the third case, it is, I can say it is C double bond OR, that means benzene, C double bond OR, this is electron withdrawing, this is minus M group. This is what we require, this is a meta-directing group. Chlorine, some students have confusion in this, it is a plus M and minus I group. If we talk about plus M, it means it donates. And where does it donate? It donates to orthopara. Although it is deactivating, but it is not meta-directing, it is orthopara directing. Next, COH is the case similar to this, right? All the groups which have A double bond B type nature, as you can see here, this is A double bond B, A double bond B, or A triple bond B, have minus M, is a minus M group. It has electron withdrawing tendencies. So fifth is correct. Ortho is oxygen is donating, so it will be ortho para donor. That is not correct. NO2 is again a minus M, a classical example of minus M group, meta director. CN, a classical example of minus M, again meta director. CH3 is having plus H, it will be donating to ortho and para. So I can see there are 4 options which are basically in which we have meta directing groups. Moving on to the next question. So in this question we have HBr and peroxide. So we know that alkene on reaction with HBr and peroxide, basically this effect is known as Kharash effect. And if we talk about the addition, this addition is anti-Markovnikov addition. Markovnikov addition. In anti-Markovnikov addition, we know H is added to the site where H is less. So if we talk about the H, the number of H is less here, so H will be added here and the bromine will be added at this point. So the product would be something like this. They are asking how many products including stereoisomers are obtained in the above reaction. So this is a chiral carbon, this is also a chiral carbon. The number of stereo centers are 2. The answer would be 2 to the power 2, which is 4. Again a very easy question, right? So that will be all for today's session. I hope you enjoyed it.